Okay, reduction formulas. It says if one of the angles in a sum or difference is a quadrantal angle, remember that means it lies on the quadrant, so it's 0, 90 degrees, 180 degrees, 270 degrees, or 360 degrees. Okay, or their radian measurements. It says if one of the sum angles in a sum or difference is a quadrantal angle, then the sum or difference identity yields a single-termed expression. Since the result is a less complicated expression, the resulting identity is called a reduction formula. So a reduction formula is just the smaller formula. It's smaller because one of the angles that's involved is a quadrantal angle. So it wants us to prove these reduction formulas. So our first one here on example 9 is sine of x plus pi is equal to negative sine of x. So we got sine of two angles being added together on the left there. So let's work the left side. And so we know that sine, this is my alpha and this would be my beta. So we're going to get sine of alpha, which is x, cosine of beta, which is pi, plus cosine of alpha, sine of beta. And we're going to prove that that is equal to negative sine of x. Well, we got sine of x. We don't know anything about x, so we can't do anything. But cosine of pi. I've got an angle there, so I ought to be thinking about my ordered pair. Pi is over on the left, so its ordered pair is negative 1, 0. Cosine is its x value, so it's going to be negative 1. So we got sine of x times negative 1 plus cosine of x times sine of pi. Sine is the y value, which is 0. So when I multiply these two, sine of x times negative 1 is a negative sine of x, plus cosine of x times 0 is 0. And so when we add them together, we just get negative sine of x, which is what we were wanting to prove that it was equal to. So that's what we had right there. So we are done with this part of the proof. Now, the second one over here says we're going to prove that cosine of x plus 3 pi over 2 is equal to sine of x. So again, on the left, I see I have a sum of cosine formula, so we know that we have identities to be able to expand that. So I'm going to work the left side. So cosine of x, cosine of 3 pi over 2, minus, because that's what the formula tells me to do, sine of the alpha, which is x, sine of the beta, which is 3 pi over 2. And we're going to prove that this is equal to positive sine of x. Alright, so 3 pi over 2. That's got an ordered pair. It's down at the bottom, so it's going to be 0, negative 1. So we got cosine of x times cosine of 3 pi over 2. Cosine is the x value. Minus sine of x times sine of 3 pi over 2. Sine is the y value, so it's times negative 1. So cosine of x times 0 is 0. Negative sine of x times negative 1 is a positive sine of x. And so when we add them, we end up with sine of x, which is what we were trying to prove that it was equal to. So you can see on both of these, because the pi on the first one and the 3 pi over 2 were quadrantal angles, they came down to just be a single trig function.